Hello again. I saw a YouTube video, it was AI generated, regarding the nova and supernova that are, I guess you could say, in the pipeline. The nova of T Corona Borealis coming up first, maybe this year, maybe next year at the latest, I think. And then the supernova of Betelgeuse, Alpha Orionis. That one's like whenever, but we're noticing that certain progressive indicators are happening there. So maybe sooner, but is sooner our lifetime? I don't know. So here's those two events. They're naturally occurring during the life cycle of stars. The nova of the Blaze star, also known as T Corona Borealis, that's the TCRB. That one is a white dwarf orbiting a red supergiant, and the gravity of the white dwarf is sucking material off the red supergiant, and that creates a hydrogen shell around the white dwarf. And when it compresses enough to ignite as a fusion source, that's when you get the nova. It may not blow away both stars because this has happened at least twice before in the known history of planet Earth. So it may just blow off some hydrogen shell, and then you'll have the white dwarf and the red supergiant again. And maybe in another 80 some odd years, it'll go boom again. Alternatively, you have the supernova of Betelgeuse. That's the red star in the shoulder of Orion. This will be an end of life for Betelgeuse. And turns out there's actually, as I refer to it, Betelgeuse has a little buddy. It has another little red star that's closely orbiting Betelgeuse in an elliptical orbit. And it's close enough to Betelgeuse that its gravity pulls away material from Betelgeuse, which will make it go supernova sooner. It did one of those close orbits about 2 years ago, and the ash from the burn off of it dragging that plasma off the star temporarily dimmed the brightness of Betelgeuse. And we have another one of those brightness dimming events that's likely going to happen later this year. And if that's the last straw, the one that broke the camel's back, so to speak, then Betelgeuse will go supernova earlier than it probably should, courtesy of its little buddy dragging material off. Because the supernova is when the internal pressure from the burning of materials in fusion gets to be less than the outer gravitational compression, then it slams into the core of the star. And when it explodes back is when you get your supernova. These are both nuclear particle physics events. The source of the events are different. One is, I guess you could say, a burp, and the other one is end of life. A nova can occur more than once. And so in the case of, if you're really up in years, you may actually see T Corona Borealis go nova twice, although the first time it went nova, probably didn't notice it, but this time you will, because we have media and social communications. The supernova of Betelgeuse will be a once-in-a-lifetime event. It only happens once in a lifetime for the star, probably only going to happen once in a lifetime for a person. These are both occurring in our galaxy. If they were to occur in another galaxy, you might notice the supernova as just kind of a little brightening spot star in another galaxy, but certainly nothing that's going to lighten up the daytime. But since it's occurring in our galaxy, we don't know when they're going to occur, not precisely predictable. So if you're going to plan a public observing event for either of these, what start date do you have for it? You can't have one because we don't know. But what's the duration? Well, the nova is going to have a slightly shorter duration than the supernova. What you're going to see in the sky is slightly different from the two of them. So what would be the start clock? How do you know when to start the planning for this? The starting gun is the arrival of a neutrino stream at Earth. Both of these events are going to produce huge volumes of neutrinos, and they're going to hit the Earth around a day or a little less before the rest of the stuff. The rest of the stuff being X-rays, gamma rays, visual, gravitational waves, all the normal stuff. Now, why are the neutrinos traveling faster than light? No, the neutrinos are also traveling at the speed of light. They're just going to be arriving sooner because they don't interact with the material of the nova or the supernova. They go right through it. So they'll just arrive sooner, whereas the gravity waves, the X-ray, gamma, and visual, those photons will interact with other materials in the detonation, and so they get held back a bit. They'll arrive slower. But how would you know when this occurs? When the neutrino stream arrives, you won't see it in public media or NASA releases until maybe days afterwards. But by then, it'll already be visible. What if you wanted to see it before it's visible by about a day? Well, you can subscribe to the NASA General Communication Network, or GCN. They will give you 24/7 alerts of all kinds of stuff, mostly gamma ray bursts, and some of those are false positives. The sun was at the right angle, and we received gamma rays from the sun, and we thought it was from a star that's on the other side of the sun, so you get false positives. Never mind if you get neutrinos and they're coming from the general part of the sky where T Corona Borealis or Betelgeuse are, and they're kind of in different parts of the sky. Then the next thing you check is who observed them. And you want to know that it's a neutrino observation, and typically those will be sourced from the Ice Cube Neutrino Observatory in Antarctica, or the Super Kamiokande neutrino detector in Japan that's buried inside of a mountain. The neutrinos themselves are not directly detected. They're indirectly detected by the rare occurrence of it energizing a water particle. And when the water particle gets accelerated and then slows back down, it has to disperse the energy somehow. So it puts out a particular wavelength of near UV blue light. In the case of Ice Cube, they have strings. That's a picture at the bottom. They have strings going down into the ice in Antarctica, where it's nice and clear ice, pure water, and the detectors are frozen into the ice, the permafrost. So they're not going anywhere. It's literally a matrix of spherical detectors. The Super Kamiokande is a giant sphere carved out inside of a mountain in Japan, and around the outer wall of the sphere inside there are all the detectors, and then they fill the sphere up with purified water, super purified water. After the neutrinos arrive, about a day later, a little less than a day later, you'll get the gamma, you'll get the gravitational waves, the X-rays, the gamma ray bursts, and the visual. The actual time at which these events occur is based upon how far away the star is from the Earth. So in the case of T Corona Borealis, I think it's around 70 or 80 light years. So it occurred a long time ago. In the case of Betelgeuse, I think it's about 600 light years away. So the actual detonation occurred 600 years ago, a long time ago. So as soon as the starting gun goes off, you have to start the planning, but you can actually start the planning beforehand, well beforehand. Treat it like as if it's a natural disaster. A natural disaster has an unpredictable exact start time and duration. But much like a natural disaster, you have to belay public fear and panic. So yeah, people are going to freak out when they see, what's that second star in the sky? How come I can see it in the daytime? Yeah, that's just Betelgeuse, sorry. So you can plan, if the starting date is here, what are all the tasks we need to do? How do we need to coordinate things? What funding do we need for it? And then you can run simulations, dress rehearsals kind of thing. It's good practice. This sort of natural event won't have any destruction associated with it. They're far enough away that it's not going to, damage the Earth's atmosphere or hurt anyone. You also don't have to file with the governor for disaster relief funding. And it's undoubtful, unless people go really berserk, that there's going to be any public infrastructure needing to be restored. So no FEMA funding. Now, here's the part that people maybe don't realize is if the neutrino starting gun occurs in the wee hours of the morning, then the actual start will occur after sunset. So you're in luck. You can see it at night. But if it occurs just after sunset, the visual indication, the visual start, will occur just after sunrise. When the starting gun goes off depends upon when you can first see it visually. The really cool thing would be if it occurs at just the right point and you know when it's going to occur in the sky, give or take, 2 hours. You can actually be there, hold the event, and then everybody stands around, milling around, talking amongst themselves, and you point up in the sky and go, there it is. And when they arrived, they didn't see it, but now they can see it. So it's like, those people back in the day that used to predict solar and lunar eclipses, you can be one of those. And then you can explain, okay, when the nova goes off, your shadow in the daytime is not going to be anything. At night, you might have a shadow, much like you have a shadow with the full moon if the skies are dark enough, and it'll be kind of white or blue-white. And then Betelgeuse, if it goes off, daytime or nighttime, you're going to have a red shadow. Now, what are good events for this? I did a whole presentation on how to plan for site locations and stuff. public parks, rooftops of buildings or parking garages, observatories outside the observatory building, museums, their patio areas or rooftops or planetariums, kind of like observatories, schools. If you have a sports field, do something in the sports field. Universities, same sort of thing. If you've got a stadium or, do it there. Going to be once in a lifetime, big time stuff. So what would be the duration? When you get the visual, it just happened. How long is it going to last? Naked eye visual brightness duration for the nova is only going to be a few days, and it's going to dim down rapidly. Betelgeuse, when it goes supernova, it might be bright in the daytime sky for a couple of months, and then it'll gradually dim down. They'll dim down to visual, to binoculars, then amateur telescopes, then professional telescopes on mountaintops, then invisible. If you arrive late to the game and you didn't do your planning, and you're going to have a public event as soon as possible after you first see it, you're probably going to go, hey, we've got an event. It's happening 2 weeks from now, and T Corona Borealis won't be naked eye visible anymore. Betelgeuse might be, but the nova won't be. So if you arrive late to the game, probably not going to have any good public observing. The actual remnant, what happens long term, in the case of T Corona Borealis, it's been a fairly dim star, about magnitude 11 for a couple of years now. After it goes nova, it's within a month or two going to be back to about magnitude 11 and go back to its long cycle. In the case of Betelgeuse, it's going to leave a permanent scar, something called a planetary nebula, where Betelgeuse used to be. Or if it collapses in on itself, it'll just be nothing visual anymore because it will become a pulsar, because that's what happens when you get a neutron star resulting from a supernova, is you get a pulsar. And pulsars spit out things in other wavelengths than visible light. And I've got two pictures down there at the bottom. The one on the left, you see the little red dot up in the upper left-hand corner? No, in the sky, there aren't lines drawn between the stars. That's just the constellation outline for Orion. You can see the 3 belt stars there. The picture on the right is my interpretation, an artist rendering as the saying goes, of if Betelgeuse produces a planetary nebula after Betelgeuse starts to dim down, you'll still be able to see the planetary nebula illuminated by the dimming Betelgeuse. So you'll see a big bruise on the sky that might have some reddish color to it up in the shoulder of Orion. And then eventually, as the supernova goes dimmer and becomes a neutron star, you'll just have, if you've ever seen the Orion Nebula, if you take out all the newborn stars, that's what you'll have. You'll have a circular or elliptical area of different gases from the expulsion by the supernova. That will be lifelong. That will be for the rest of your life and your children's lives and your grandchildren's lives. And you will have lived in a time when you saw it beforehand, when it was the picture on the left, and then you saw it for the rest of your life like it is on the right. So I've produced a number of videos for the Broward Astronomy YouTube channel regarding related topics: the supernova, starting gun notifications, event site planning on short notice, Cherenkov radiation, and then if you have something like neutrino or gravitational wave events, they might produce optical visual observing, but it might require professional grade telescopes to see it. I've been watching a steady increase of social media creators forecasting the end result of what is this, and so I put some links at the end of the presentation. Novas and supernovas, they're just points in the lifetimes of stars. And they're going to be different based upon each star, its timelines, and whether they recur or not. Novas are potentially recurring, maybe once or twice in a lifetime for the same star. Supernovas are literally once in a lifetime events, never occurring again in a single lifetime for that star. Neutrinos arrive first. Look for that first. The public observing start clock starts with the neutrinos, rapid turnaround planning. Within less than a day, all of a sudden it'll switch on visually. So plan your public observing accordingly. Both T Corona Borealis in our galaxy and Betelgeuse, also in our galaxy. In the case of the nova, if you're young enough, you might see it twice in your lifetime. If you're older, like myself, this will be the first and only time you'll see it because it's longer than most lifetimes. Might not be visible in the daytime, but it will certainly be naked eye visible at night for a while, maybe a few days, and it'll fade. Unless it self-destructs when it goes back to its normal state, T Corona Borealis will still be a roughly magnitude 11 faint dim star. In the case of Betelgeuse, once it goes bang, it will no longer be the red supergiant star it once was. If you're alive when it happens, you will know before and after. And it will most likely be daytime visible for a short time, which is going to freak people the hell out. Naked eye observing probably for about a month, and that afterwards telescope. But if it becomes a neutron star, it may be visible in radio astronomy. We don't know the frequency yet because that depends upon the spin rate. And then links and more links. And then all of the Broward Astronomy YouTube channel videos. Comments? Question?
I hope Betelgeuse blows up during our lifetimes. That would be so amazing to see that.
I think the value of astronomy and science in general will be elevated by quite a bit if all of a sudden there's a second star in the daytime sky. If you go back and look at the historical YouTube videos, I've been leaning into this for 2+ years. So when it does occur, it's like, who knew about all this stuff? Amateur astronomers.
Yeah.
Did anybody say anything in advance? Yes. What's going to happen to us? I think the most interesting thing, aside from being two stars in the sky, is when the gamma ray burst from the nuclear detonation occurs for either one of these, there will be a lot of radiation that will impact the upper atmosphere of the Earth. I don't suspect it will be that much for T Corona Borealis, but for Betelgeuse, I mean, it's not going to harm any life on the planet, but I think it will be enough to excite the aurora. That would be something, because if when it detonates, it's in the lower latitudes, the lower elevations, because constellations move over the course of the night as the Earth rotates. If it happens to detonate when it's near the horizon, you'll have aurora in Florida, South Florida, for the first time. That would be something worth looking at, aside from, having a second star in the daytime and seeing your red shadow at night and something brighter than the full moon at night. Yeah, that would all be very interesting. But seeing basically a hemispherical aurora on the Earth, it might last for a couple of days. I think that would be very interesting. Okay, any other comments or questions before I stop recording? Hearing nothing.